Yes.
Are we doing 6.2 also?
Yes.
Okay.
I'm going to probably cover some questions today that will take care of presenting it. So I'll probably present and go over questions at the same time.
Okay.
Just a minute. Let's see. Meeting details. Meeting options. There we go. Where is the lobby on Teams? Does anybody know where the lobby is?
The lobby?
I'll have to ask that. I'll have to go to Google and ask that. It says who can bypass the lobby? I'll have to check on that. I'm talking to myself. You just have to ignore me.
You're fine.
Trying to think of any announcements. I don't have any announcements. We're just going to do problems. So do that. All right. So the first one we got some repeats here. And we got like 15 number 18s. So I'm going to do one. And that, therefore, most of y'all can take it from there. 6.1, 18/6. 6.1, 18/6. Now, Miss Yoakum, you're not allowed to yawn in my class, so.
Sorry.
That's all right. You yawn 2 more times and I'll have to ask you to leave. Okay, first of all, I'm going to take this to the Excel spreadsheet. I'm not going to worry about what they're asking here. I'm just going to go, we're going to do everything we can to this binomial distribution. And everything that I do is what I think is important and what I will test you on. So here we go. Let me make this a little bit bigger for you. So I want you to go ahead and write that down. There is your binomial distribution, and I will also center it because I can't stand to have stuff not centered. And might as well go ahead and make that bold and underline. I will tell you this, though. I've got a new show that kind of goes with my teaching style that I'm recording and binge watching. And that is called, it's been on for a while, at least 5 or 6 seasons. Anybody ever heard of Bar Rescue? Oh my gosh. If you ever think you're the dumbest person in the world, watch Bar Rescue. Because there's some people that owns bars, they shouldn't even own a car, much less own a bar.
Well, I think owning a bar is a bad thing to do, so.
Well, it's a free country. Anybody can do what they want to. You can't judge. There's only one person that can do that, and he walked on water. Or he ascended, you know, Allah ascended and all that good stuff. I mean, not Allah. Oh, gosh, I can't think of Muhammad. You know, whoever you believe in, or Buddha, or whatever. I have to leave that open to all areas. Got to have diversity. But anyway, the reason I watch it is because that guy tells you if you're lazy and stupid. That's why I like it. These people are like, I'm not lazy. No, you don't clean the bathrooms, you don't clean the kitchen, you don't clean the bar. You're lazy. So I love watching that show. Anybody ever seen it? It's a good show.
I watched the one that Ramsey did for restaurants a few times.
Okay, say again, Mr. Jacob. What?
I watched the ones that Gordon Ramsay did for restaurants a few times.
Gordon Ramsay? Oh my gosh, you watch Gordon Ramsay? You're a terrorist.
Oh.
Yep, you're a terrorist. If you watch Gordon Ramsay, you're a terrorist.
Well, I'll keep that in mind next time I watch it.
I'm being sarcastic. Who else said they seen it before? I saw somebody else say something.
It was me.
Okay, say it again because your light goes off as soon as you say something.
It was me.
Okay, Miss Lusk, how do you like bar rescue?
It's really entertaining and fun,
It
but
is.
it's kind of gross.
It is. I can't believe people are that stupid. I can't. I cannot believe it. I hope they're acting that stupid, because if somebody is really that stupid and that lazy, they don't deserve owning a business. Anyway, all right. So what are we going to do? Well, let's go back to our handy dandy. Let's go back to our handy dandy formulas. Let's see. What can we find? We can find the mean is equal to the summation of x times p of x. And we can go with our variance is equal to the summation of x squared times p of x minus mu squared. And then what is the standard deviation? And I'm going to say this 5,000 times before the semester's over. I've already said it about 2,500 times. What is the standard deviation's relationship to the variance?
Isn't it the square root of the variance?
Yep. Or variance raised to the second 0.5 power. Okay, now remember I told you these things right here, you got to know, you got to read. So what do we need to do to our what do we need to do to our probability distribution before we even get started? What do we need to do before we even do any calculations? What do we need to do? Look in your notes. There's something we do before we start calculating.
Is it find the sum of the
Okay.
probabilities?
The test, the two tests. What are the two tests? The summation
if
of
it's-
all the probabilities has to equal what?
It needs to equal 1 and
And
be
each
between
probability should be what?
0 and 1.
Yep. And again, that's something I told y'all the first day of 6.1. So let's get to work. Let's get to work and look at all these numbers. So each one of these, are they between 0 and 1?
Yes.
Yep. So that works. And let's add them up. And there is our 1. So it does meet the criteria. So what's next? Well, we just checked these two. So let's put a check. I'm going to use my green marker. Let's put a check right here and a check right here. So what else is left? These over here. Well, they say they want us to draw a graph. So let's draw a graph right quick. And you can do this on your calculator. We'll do it on your calculator if you want to. Insert. I'm just going to do a chart plot because I don't, there it is. So I'm going to delete this in just a second, but you need to go ahead and draw a sketch of it, please. So I'm going to draw a sketch of it on my paper here. So we got one about midways, and then we got one up here, and then we got one down here, and one right here, and one right here, and one right here. So somebody, if you put all those dots together, what kind of line, we have a skewed left, skewed right, or normal curve?
Skewed right.
Skewed right. Good job. Mr. Michelle, you know you're not supposed to, use notes and write down this stuff and remember this stuff. You know that, don't you? You're supposed to forget it as soon as I say it. Somebody needs to get to you, Mr. Michelle. You're not doing things right.
You see, I'm trying to, but your voice won't stop getting out of my head.
I know. Let me delete this. All right. So we've got so far, what do we have? Let's see. We did the test, and we've done a graph. So number 1, do a test. 2, sketch out a graph, and this is number 3. So now all that's left is calculations. So let's look at our formula. What does our formula say? X times what?
P of X.
So that means I'm going to take these 2 columns and I'm going to multiply them. So I'm going to call this column X times P of X. And I'm going to make it a little bit wider and equals this times this, and enter. All right, check your numbers. So we're going to highlight this yellow, and that means that we're given that material. That's given. I'm going to highlight this kind of a pink color. I don't like those colors, so I'm going to go with a pink. And we're going to highlight this pink. And that's going to be the summation. And that is mu. So I'm going to take my handy dandy pink highlighter, and we're going to highlight. We just did the mean of the probability distribution. And that is 0.919. Mu is equal to 0.919.
Can you show me the Excel for that again real quick?
Just add them all up. Oops, what happened to my... Hold on, Miss Macagina. Something disappeared. Everything disappeared. Y'all disappeared. My spreadsheet disappeared. There we go.
Okay,
Okay,
but then
what does the formula say? X times what?
asterisk.
X times P of X. So that means I'm going to take that times that and then add them all up. So which one you need to see? This one?
Yeah.
There you go.
Okay. So you did 0 times 0.273.
All of
And
these. You add them all up.
Okay, you did them in like. Okay, yeah. So you did them like 0 times the one next to it, and then 1 times the one next to it, and then 2 or.
Okay, I'm confused with your question.
I'm confused how to explain
Okay,
it.
go to your first square. X times P of X. 0 times 2.73 is 0.
Yeah.
1 times 573 is 573.
Mm-hmm.
2 times 122 is 244.
Okay, I get it now. I get it.
X
So you just
times
add.
P of X.
Okay. Okay. So then you just add them all up, and that's your mean.
Yep.
Okay.
And that right there is your mean.
Okay. Thank you.
Mm-hmm. Okay, so let's go to our formula. Variance. And I'm going to go through and I'm going to highlight in blue everything we already have. We've got mu. We've got P of X. What do we not have? The only thing not highlighted. What do we not have?
Standard deviation.
No, right here.
Oh, x squared.
X squared. So I got to make a column called X squared. Now, you don't have to do this in your calculator. I think all of you can do 1 through 5 squared, but we're going to do it anyway just for giggles. Well, it didn't do it. Equals this raised to the second power. Now let me copy it down. There we go. All right, so let's go back to our formula and read our formula. What are we going to do to get the variance? Somebody tell me, what do we do first? Take my handy
You
dandy.
add up x squared
Times what?
times p of x.
X squared times P of X. So we got to make a new column called X squared times P of X. So I'm going to call this one right here X squared times P of X. Okay, again, it's not rocket science, okay? Equals X squared times P of X. 0 times anything is what?
0.
That's what you get. What's 1 times anything? That number. Four times 0.122 is 488. 9 times 0.027. 16 times 0.004. 25 times 0.001. Let's take a orange highlighter, and I'm going to highlight this area. Orange. I saw that, Miss Yoakum. We all know what's in there.
It's just coffee.
Yeah. Yeah, so is mine. Orange. And I'm going to highlight this orange. And I'm going to take my highlighter right quick. And this is orange. And what am I going to do with that orange? I'm going to do what?
Add them all up.
Add them all up. Red Solo Cup. There you go. So that orange is 1.393. That's right here. I'm going to write it in orange right here. 1.393. And what am I going to subtract from it? That means I want y'all to say something.
The mean, which is 0.919.
Mean what?
Squared.
Mean squared. So I'm going to write 0.919 and square it in blue. So I'm going to go down here. I'm going to leave that there for you for a second. 1.393, that's right there, minus 0.919 raised to the second power. So I'm going to go down here and do that. I'm going to call it the variance. Oops, page up. Sorry about that. Equals this number minus parentheses this number raised to the what? Second power. There's my variance, and the standard deviation is that number raised to the what? 0.5 power. That's right. And these are the rest of our numbers that we need. So I'm going to highlight those. I don't know what color. I'm going to see if I can find a good color. Let's go with that fluorescent looking. Green. So our variance and our standard deviation is numbers that we need. So let's go back to our handy dandy whiteboard, and I'm going to write down, we do have a binomial, we do have a polynomial, I'm sorry, a probability distribution because of our test. We have a sketch of the graph. 3, we have the mean. And 4, we have the variance and the standard deviation. And our mean is equal to 0.919. And our variance and standard deviation, 0.5484. And 0.7406. Now this is what I will test you on. Those are all 4 of these are good test questions. 1, 2, 3, and 4. Technically, you could call them 5 because this is number 4 and this is number 5, but I kind of consider this one thing because you're just taking the square root. So that's all I care that you be able to do out of chapter 6.1. So if you can do this problem out of 6.1, then you can handle it. Now they ask a Philadelphia lawyer question in here, and I'm just going to tell you what the answer is because it doesn't make a lot of sense to me. So I'm not going to ask you. If it doesn't make sense to me, it ain't going to make sense to you. So Miss Yoakum, did you draw that picture behind you, or is that a TV screen with the beach behind you?
No, it's we're down on vacation, so it's just one of the pictures that's.
Oh, where'd you go to vacation?
We're in Marathon, Key West area.
So you're in Florida.
All the way to the end of it.
What about you being able to attend class and you're in Florida? Ain't that great? That's called dedication. You're going to have a nice office one day, Miss Yoakum. All right. So this is a discrete probability because all the probabilities are between 0 and 1 inclusive, and the sum of the probabilities is 1. Where is that, Hubert? Well, that's right here. We check that. Which one is skewed right? Well, this one is skewed left. That's not it. This one is skewed left. That's not it. This one is all over the place, so it has to be alpha. The distribution has one mode and is skewed right. Well, I just said that. What is the mean? 0.919. What does it say round to? It doesn't say round. 0.919. And you feel good about yourself. This is the Philadelphia lawyer question. Just remember, to be the man, you got to beat the man. Anybody know who said that? Oh, come
Ric
on.
Flair.
To be the man, you got to beat the man. Nobody?
Yeah, that was Ric Flair.
Ric Flair. So that would be, the reason I said that is so you can remember it. Right here.
Woo!
To be, that was a good imitation. To be the man, to be the mean, you got to be the mean. And that meaning right there. So delta. Was that Miss Macagina that gave me that good imitation of Ric Flair? I'm just kidding. Miss Macagina don't even know who Ric Flair is. What is the standard deviation? It says round to one decimal place. We got 0.7. What is the probability that a randomly selected individual is involved with two marriages? Somebody tell me that answer.
Would be a 0.122.
How did you get that, Mr. Michelle?
Just because of the chart on the top
Just
right.
look at the chart. Okay. What does at least 2 mean? Well, I'm going to show you. And this is part of 6.1 and 6.2. When you see the word at least and at most, remember, I'm going to go to my handy dandy whiteboard here. And when you're talking about 6.1 and 6.2, can you have a decimal household?
No.
No. Can you have a fraction of a boy?
No.
No. Can you have part of a body? No. So in 6.1 and 6.2, as far as people surveyed, as far as children asked, as far as households that have TVs, as far as people that are above 15 years old, all of those are going to be not decimal, not fractions, not parts, but what kind of numbers?
Discrete numbers.
What?
Oh, whole numbers.
Whole numbers / integers. Can you have -3 households? No. So we're talking about positive wholes and positive integers. So if I give you a number line and 0, 1, 2, 3, 4, and this is 5, and I say in blue, now this is very important. You need to write this down so you don't screw this up. If I say at least 2, somebody tell me in layman's terms what at least 2 means?
2 and above.
2 and above. That's one way to look at it. Give me another. The lowest number has to be what?
2.
2.
Okay, that's another way to write it. So if you wanted to graph 2 and above and lowest number has to be 2, it would be like this, wouldn't it? Wouldn't that be at least 2? So I would take the probabilities and I would do what with them?
Add them up.
I would add the probabilities of 2, 3, 4, and 5 for at least 2. So take it back to my, so that's going to be 0.001, 0.004, and you do not need a calculator for this. 0.027 and 0.122. Well, 12.2 cents, and I like to treat my numbers as money because money is important to all of us. And if you don't believe that, the only 2 things that's important to us is time and money. And people say, oh, well, money's not important to me. Bull crap. You pay your bills, don't you? All right. So 12.2 cents, that's 14.9 cents, 15.3 cents, 15.4 cents. So that's going to be 0.154. Somebody check me with a calculator, please. I need somebody to type in those 4 numbers and add them, please.
Yes, sir. That's what I got.
Okay, good job. So that would be 0.154. Okay, now please write down this question, number 18. There is 1, 2, 3, 4. I'm not counting this one. 5, 6, 7. There are 7 good test questions on this problem, excluding the Philadelphia lawyer question. There's 7. So if you want to know what I'm going to test you on, number 18 is a good example. Now, I would not give you this one on one single test question, but all of these questions right here are good test questions that I would put on a test. All right, so that takes care of number 18. I don't have much time, but I did like 7 questions there. So that's number 18. So that takes care of all of these. The next question is 6.123/7. I've got about 9 minutes. I don't know, what time is this class over? 11?
11:05.
Thank you, Miss Macagina. Appreciate you communicating.
You're welcome.
23/7. And this takes care of 2 questions that were sent in. And somebody just sent another question in. I don't know where it came from. But anyway, let's see what it says, and I'll tell you first if it's a good test question. Okay, the graph of the discrete probability represents the number of live births by a mother, 46 to 51. Good gracious. Who had a live birth in 2015. What is the probability that has had 4 live births in that year? 0.111. So you should be able to read a graph. 0.111. I'm just reading the graph. What is the probability that a randomly selected blah, 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 blah has had her 4th or 5th birth in that year? 0.111 plus 102 is 0.213. Add them together. What is the probability that a randomly blah, 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 blah had her 6 or more? 6 or more means what? 6, 7, and what? 8. I got to blow this thing up. That's just too small. There we go. 6, 7, and 8. Okay. 4.3, 6.9, 11.7.117. Somebody check my math.
Yes, sir.
And check it. Ooh, I must be off. Somebody add it up again. 6 or more. We'll add those up again. Make sure.
Um, 0.097.
0.097. I must have added something wrong. My bad. Sorry. Blah, 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 blah. Okay, what does it say? If a 46 to 51-year-old mother who had a live birth in 2015 is randomly selected, how many births would you expect the mother-in-law to have? They're wanting the mean. So you're going to have to add all these up. Or you're going to have to multiply them all. They're wanting the mean. So 0 times 0 is 0. 1 times 234. 2 times 284. 3 times 172. 4 times, I'm just going to type it in the calculator. So I'm going to go over here and I'm going to type it in the calculator. Let me clear everything. Y'all ready? So stat, edit, 0, 1, 2, 3, 4, 5, 6, 7, 8. Everybody with me?
Mm-hmm.
And 0, 0.2, shoot, 0.234, 0.284, 0.172, 0.111, 0.102, 0.023, 0.026, 0.048. Now, I'm going to hit stat. Watch this now. Stat, calculate, enter on number 1, first variable stat. L1, I'm going to change frequency list to L2, second 2, and calculate. And my mean is equal to 2.976. Now I want to ask y'all a question. Can you be 0.976 pregnant?
No.
So somebody tell me how many pregnancies we're talking about.
1.
1.
Come on now, look at the number. You're not looking at the number now.
2.
2.976.
3.
3. So we're talking about 3. Now, before I go back to the question, it's probably going to say round to the nearest whole number because you can't be 0.976 pregnant. Round to 1 decimal. Wow, that I wasn't expecting that. Well, 1 decimal place, that would be 3, unless they want 2.10, which that you can't have that. Oh my gosh, we got it right. Is this a good test question? Yeah, you got 4 good test questions right here. 4 good test questions, and that's going to be it for today. So I'm sorry I didn't get very far, but the reason I didn't is because we did basically, in 2 questions, we did what? 11 questions. So there's nothing wrong with that. All right. So I hadn't finished 6.2, but I hadn't even gone into 6. Have I gone into 6.2 with y'all yet?
No, sir.
Okay, so continue to work on 6.2, 6.1, and I have given y'all at least to where y'all can get through 23 at least. But anyway, keep working on them, and we're going to close it down, and I will see y'all Wednesday, okay?
Yes, sir. Sounds good.